Alcohol contain a hydroxy group bonded to an sp3 hybridized carbon atom. In naming alcohol, first is you need to identify the longest carbon chain or the parent chain that the functional group is the priority or has the lowest number.
So at the first example, the alcohol is located at the second carbon, so we will name it as 2-propanol, also known as isopropyl alcohol. So at the next example, the alcohol is located at the second carbon chain, and also there is a methyl group found, so we will name it as 2-methyl-2-propanol, also known as third butyl alcohol. So what if we have two hydroxy group attached on one carbon chain? So what we want to do is identify where is the alcohol is located and find the lowest possible nomenclature, then count the number of carbons and add di because we have two oxygen, so we will name it as 3,4-hexane diol. So in cyclic chain, first is you need to prioritize the alcohol group. So in here we have 5 carbon attached to the alcohol, so we will name it as cyclopentanol. In drawing structure, so first what you're gonna do is count the number of carbons. So we have 4. Then attach the hydroxy group at carbon 1 because it is the priority. Then the methoxy group at the 4th carbon chain. So we will name it as 4-methoxy-1-butanol.
For example, we have this structure. So how do we name this? First, we have to figure out what functional group we can see in this structure. So we have a benzene, and then amide. So instead of writing benzene, since we are in an amide group, we replace the ene with our primary functional group, which is amide. So the name of this structure is now benzamide. Now let us proceed with drawing the structure. For example, we have a 2-bromobutanamide. 2-bromobutanamide. So, as we all can see, we have the word butan, which means 4, so we will be drawing 4 carbon chains, 1, 2, 3, 4, and now we can add our amide right here. Since it is 2-bromo, we are going to place our bromine on the second carbon chain. So we should start cutting here, 1, 2, 3, 4, and this is our second carbon chain. That is where we place our Br. Now our structure would be like this.
Naming ester. In the molecule that is given here is an ester. I can tell it by its general form. Here on the left side is an R group, and then in the center is a carbonate group. Attached to it is an oxygen and then another R group. So the general structure, our carbonate group attached to an oxygen attached to an R group is an ester. First, the family name is OA. Then identify the carbonyl carbon. Second, the parent chain. The carbonyl carbon gets the lowest number possible in ester. Therefore, in this molecule, it is ethyl butanoate. Drawing esters. First, you have to look for the family name. Usually, we have to start looking from right to left side to understand it. And because it ends with OA, it is an ester. We have to draw down the general structure. And because the rest of it now is R groups, and the rest in the name will tell us what those are. The parent name and then the other side of the oxygen.
So now let us proceed to the naming of the aldehydes. Again, we have factors to consider. The first one is to locate the parent chain. Identify the lowest possible position of the substituents, and the CHO group must always be counted as the first carbon. Change the E ending of the parent alkane to the suffix -al. So we've got the first example here. First, number the carbon chains and identify the CHO as the carbon 1. So we've got 4 carbons, which is butane. Exclude the letter E and change it with the suffix -al. We've got methyl on the third carbon, so therefore the compound is 3-methyl-butanol. For the next example, we've got 5 carbons and a double bond on the carbon 4. Therefore, it would be 4-pentene. Exclude the letter E and exchange it with the suffix -al. So it would be 4-pentanal. So for the last example, we've got cyclohexane. If the CHO group is bonded to a ring, name the ring and add the suffix carbaldehyde. So in this example, you just have to name the compound and then add the suffix carbaldehyde.
Good day everyone, I am John Andrew R. Ureta, and in this part, I am going to discuss on how to name and how to draw the structures of ketones. In our first example, we have 3 carbon chain, meaning our parent chain is propane. Change the E ending of our parent chain to O and E to have propanone. Propanone is the most common ketone. It is also known as acetone, which is effective in polishing nails. In the next example, we have 5 carbon chain and 1 substituent. Enable for ketones to obtain low position, we need to count from right to left. So our substituent is positioned at the 3rd carbon and the ketone is located at the 2nd carbon. And we have 3-methyl, 2-pentanone. In this example, we have 6 carbon chains from the root word hexa. Then determine the functional group and the substituent. So our substituent bromo is positioned at the 5th carbon and our functional group or ketone is placed at the 2nd carbon. So therefore, we have this structure of 5-bromo, 2-hexanone. Another example, feel free to pause. So we need to draw the structure of 3-methyl cyclohexanone. So first, draw the structure of the parent chain, which is cyclohex. And in cyclic structures, ketones are assigned to the first position. Then determine the position of our substituent, and we have the structure of 3-methyl cyclohexanone.